So Dann is my father's company, and Smart Lab is mine. Just a brief of who am I. I'm a guy who grew up in Hamburg, sitting around electronics all day. I moved to the UK, went and studied there, did a Masters of Dann in Engineering, and I've come back to start a business and try and help my dad with his, if possible. So Smart Level is just a breakout of some of my dad's products, specifically mining and density and level stuff in the mining sector. My father's business is Dann. It's been around for a long time. It's got a huge range of products, a lot of different variations, bits and pieces, which make it very good for customers, where we can customize and adapt the products and use different bits and pieces and mix and match to meet their requirements. Some of these are, we're going to look at here. We're tying up some of these to the Netbiter stuff that I mentioned earlier. These products range from things which I'll talk about the AIM08 here, control applications in the MCI, all of my business stuff, which is the Smart Level side, vibration applications, all sorts of things really. The AIM08 specifically is an analog input module. It has galvanically isolated inputs, which makes it nice for a lot of systems. The inputs are all customizable, so we can do anything from 4 to 20 millivolt inputs, plus or minus voltages, anything really. These are all put onto a system which is Modbus enabled, and then which connects to the Netbiter. These are adaptable to really any system that people can think of as inputs. The applications that we have for these, currently we're running in some cell phone towers for battery monitoring. Because of the laws regarding sharing of these towers, we have to monitor them. We have other stuff which I mentioned, the vibration sensing, large distributed systems, collation of information and presentation on networks where people can specifically target one device and pull data directly from it. And sensor clusters, which is, I'm going to go into more detail, but this is for water monitoring, customizable as per user requirements. One of these applications is fish farming, specifically for our water quality side. And fish farming is great because it's a huge market which has a lot of potential, which is very small in South Africa. So there's a lot of opportunities to do very well in that market. These fish farms have a lot of stuff preventing them starting up in our history here with rules, which they seem to be getting through now. So there's a lot of interest in that field. The AIM water quality is a prototype system at the moment. We have our prototype unit and an example of what we think the final unit will look like. This is one of the units is currently installed in a fish farm in Mildersdrift called Rudawi. This is a fish farm which has won a lot of awards for innovation, for sustainable development, things like that. And it's working with the local universities, trying to develop this stuff. I think they've done some stuff called Fish in a Box, which is very interesting. And they're doing a lot of stuff in Southern Africa, in rural and poor regions. The fish farming is actually really great because the yields for the fish are very high for the feed, which makes it excellent for very remote or very poor regions. And we're looking to add some automation to that at reasonable prices. This is what our box is at the moment as a prototype. Currently, we only have air and water in the system, and the guys on site are very excited with just that because they don't have to monitor it all the time. We will be, and we have a demo outside, we will be showing a lot of these. Currently, we've got pH and ORP, which I think I've got put on the list, but outside they're demoing already. And we're going to hope to install those next week. The fish farm guys, as mentioned, are very excited with just temperature because this is an example of their monitoring that they're doing at the moment. This monitoring is every hour, every tank, all of these pH, ammonia, temperature, fish responsiveness, feeding, it really becomes a huge deal to monitor this stuff and to manage it. So they have 5 guys just all day, all night doing this, and it really gets out of hand very quickly. Below here is an example of our logging that we're doing. So the yellow is air and the blue is the water temperature. And you can see some cold days and stuff as it goes through, but the key here is it's a log every 5 minutes, 24 hours a day, that the people don't have to actively do themselves. And obviously this will get like a whole lot more interesting when we get the rest, and I shudder to think how excited they'll be then. The mining side, my side, is specifically looking at potential installations in Kibali, which is a gold mine in DRC. We're installed about there on the thickener tank over here, which is to separate the slurry and recover the gold. Obviously this is a long way from us, a long way from anywhere really. And there's a lot of money involved. So any stoppages, any alarms that they want, like monitoring. They had a situation recently where some power failed and one of our systems got hooked up and it nearly caused a stoppage, and a lot of people were very upset. So monitoring is a very, very high priority for us. The thickener itself is effectively a feed-in of material with a polymer to bind stuff and sediment it out. This sedimentation is raked and then pumped out at a rate. So the key to our product is that we can monitor the levels in this, monitor that mud bed there, and give it precise, give it if it's a clear step or a gradual change. And this, then they can optimize their system, which means they can process 5, 10, 15% more material, which means that it's 5, 10, 15% more profit potentially. So the guys are very keen on this, but we need to be able to have it installed in a manner which is safe and has a lot of safety mechanisms to prevent problems. Because every stoppage for them is $10,000 to $100,000. It's a lot of money. The sensor we're using for this system is this over here. It's our Sonar TXM. It's a density profiling system which uses some ultrasonic measurements. So we're like returning a mud bed level, but really we can actually do a full profile. So we're looking to write some papers and stuff on those profiles, on the materials going through, and see if we can optimize the stuff in other situations. This, as you saw before over here, there's a rate going around. So this is not a static system. You have to roll it in and out of the water all the time, avoiding the rake. This over here is our drum mechanism. We're hoping to put a Netbiter in here at some point in the future. And this is the SCADA system that this is what they're receiving. And this over here is what they saw when they had a major problem in the tank. And that probably slowed their production by about 70%. Just that there. So the guys are very keen to get this stuff in, predict it ahead of time, monitor remotely, get alarms. So this product here is very useful to us. In our future ideas, we're looking to do solar monitoring, battery monitoring, like remote stuff. Long-term analysis of this stuff, specifically in the mining side, because this data doesn't exist, and being able to get it to us over long periods of time is very, very valuable. Also, to create systems that we can install and customize on a per user basis is also very powerful. So it's nice to have an interface which we can adapt and modify very easily, very quickly, even teach the customer how to adapt themselves if they wish. And another thing we're looking at doing is centralized monitoring. So getting it so that we can have one guy who's an expert in his field monitoring a whole bunch of mines rather than an expert at every mine, which can save them a lot of money. So if we have any further questions, you can either visit my website or my father's website, or have a word with outside. Thank you very much.